All right, in this video, we're going to learn about 4.3 scatter plots and line of fits. So this relates to benchmark DP.2.4. We're going to fit a linear function to bivariate numerical data that suggests a linear association and interpret the slope and y-intercept of the model. So we're going to use the model to solve the real-world problems in terms of the context of the data. So as a review, a scatter plot is a graph in the coordinate plane representing a set of bivariate numerical data that is used to observe a relationship between two variables. A line of fit is just a line that's drawn on a scatter plot to estimate the relationship between two sets of data. A line of fit can also be known as a trend line. So in example 1 in our notes, we were given a table and we were given a graph. And the first thing we need to do is draw a line of fit that passes through the data. So I'm going to go ahead and draw that line of fit. And it's going to follow the data points. And it also needs to lie in the middle of the data points. So an equal number of points both above and below the line. That's how you know if you have a good line of fit. Now we need to write an equation of the line of fit, and it passes through the data points 0.90, 9.9, and that's this point right here on our graph, and this ordered pair that's listed in our table. The other point we're going to use is 40 and 3.6. So see how that point falls directly on the line? Well, that point I know is 3.6 because it tells me that data, that information in the table. So those are the 2 points that I'm going to use to find the slope. And I can do this by doing y2 minus y1 over x2 minus x1. So I've labeled my points, x1 and y1, x2 and y2. And then I'm going to set up my formula, my slope formula. So my y values will be in my numerator and my x values in my denominator. And yes, I know I have decimals, but a decimal is no different than a whole number. We just have to put a point in the middle of it when we're using a calculator. And since we are allowed to use a calculator, you should not fret with decimals. So once I do my calculations, I get negative 6.3 divided by 40. And when I put that into a calculator, I get negative 0.1575. So that is going to be my slope, what I'm going to use for my m value. Now I can select a point from the table or from my given points to write an equation. Well, luckily, in this particular example, I was given my y-intercept, so I'm going to use my y-intercept, 0 and 9.9, to write an equation. Now this one says to write it in point slope form, y minus y1 equals m times x minus x1. So I'm going to fill in my x and my y value into my point slope form. And then I'm going to simplify it. So y minus 9.9, because that's my y value, equals negative 0.1575x. I didn't want to leave the minus 0 because that would simplify to nothing. So I just simplified it in the way that it would actually be written. And I don't have to do anything else at this point because it said to leave in point slope form. And you're going to see point slope form on your test in a few days. So we just need to make sure that we understand it and know how to use it. Now it also said that we could use the y-intercept 0, 9.9 to write an equation in slope-intercept form. And so if I'm going to use that and write it in slope-intercept form, it's just y is equal to negative 0.1575x plus 9.9, which also makes logical sense because if I moved this 9.9 over to this side of the equal sign, I would add it and then I would be in slope-intercept form. So now I have to use this data or this equation, from step 2 to predict the temperature when there is 1 inch of snow. So I have my slope and I have my y-intercept, and this 1 inch of snow is talking about my y value right here, 1 inch of snow, and see how my graph doesn't include that? Well, I can use my equation now to predict what it would be, what the temperature would be when there's 1 inch of snow. So I'm going to plug this 1 in for my y value, and I can use either my point slope form or my slope-intercept form to plug in the 1. I chose to use my point-slope form because I thought it would be easier. So when I do 1 minus 9.9, I get negative 8.9 equals negative 0.1575x. And then I have to divide negative 8.9 by negative 0.1575x, and I get 56.5 because I'm going to round to the nearest tenth because all of the numbers in my table were also rounded to the nearest tenth. So I'm just going to try to be the same. So what did I find? My x value is equal to 56.5. Great. But what does that represent? Well, my x values here are talking about temperature. So it represents the temperature in degrees when there is 1 inch of snow left on the ground. All right. Now I want you to go ahead and try the check. The check, you were given the points 10 and 20 and 50 and 8. And I went ahead and drew that trend line for you. And I'm going to get you started and just highlight those points. And then I want you to complete it and write your equation on your own. Remember to use what you learned from Module 2 as far as how to find your y-intercept, because here our y-intercept is not given to us in the table and it's not a point on our graph. So I'm going to get you there. I'm only going to give you this part. So your slope of 3/2. Now I want you to go ahead and write the equation on your own and solve the B part, and you can complete this check in Canvas to see if you got it right. If you didn't get it right, you can review what you got wrong and it will show you the finished slide. All right, once you finish the check, then you can work on the practice. You may come and see Ms. Shashagwe if you have any questions.